Welcome. Let's look at equations where we're going to solve exponential and logarithmic ones. So the first thing is to recognize that in section 3.4 there are a number of examples, and this is a progression of techniques shown through those. And we're going to do some of these different ones. Okay, so I would highly recommend to practice each of these different types of things, and we'll do some of these in these examples here. So let's start off here with this type, where we have 45 raised to the power of x minus 7 equals 350. So the way we're going to do this one is we are going to apply logs to both sides. So what I get, logarithm of 45 to the x minus 7 is equal to the logarithm of 350. And the reason I'm going to do that is because that now allows us to take this, which is in parentheses, and put it in front because of the power property. Now what we have is an x minus 7 that's in front of log 45 equals log 350. So what we now do is we're going to divide both sides by the log of 450, or 45, 450, 45. I'm sorry if I said that wrong. Log of 45. And we're going to pick it up here. So now we have x minus 7 is equal to the log of 350 divided by the log of 45. Oops, didn't mean to make that so big. Let's do it. I'll bring it back. All I wanted to fix was this 5 and 0, and make that clearer to see. Yeah, that's better. And now we'll add 7 to both sides. So we have x is equal to the log of 350 over log 45 plus 7. And when you put all that into the calculator, that comes to approximately x is 8.5389. And so we'll round. Now, logarithms have to be to 4 decimal places. So we're solving for the x here, so it's not a logarithmic number. But once we do get this for the log, we can then round it. So it looks like I could either make that a 4 or I could round it to a 5. So I do approximately 8.5. Now, you could put that back into here. If we put 8.5 into here, and we have 8.5 minus 7, so it'd be about 1.5, give or take. And if you put that into the calculator, you would find that 45 to the 1.5 power is 350, approximately. Let's make that a little bit neater. So 8.5 minus 7 is about 1.5. Yeah, it's a little bit better. Aha. If I go like this, it'll make it clear. And now I'll erase it to make it clearer. 1.5 as a result of putting 8.5 in there. Okay, now I have that better. Let's do the next one. Same exact concept, but this one's going to have a complication to it. Okay, so going back to the number part 2 here, okay, we had to take that and put it down in front. And that was really the only complicated thing, and it wasn't all that complicated. But notice now that we have 2 x's in here, and we have to get one single x equals like we did over here. Okay? Oh, and I need to go like so. Now here, we're going to do the same basic thing of applying logarithms to both sides. 24 5x minus 2 equals log of 9 to the x minus 1. So that means for both of these, the next step is going to be, both sides is going to be to put the exponent in front using the power property. So that means we have 5x minus 2 here in front of the log 24 equals x minus 1 log of 9. Before, we were able to just divide on both sides. Now, we can't really actually do that. Okay, because we have two x's here, that really complicates some of what we do. So we're actually going to have to multiply the logs in. We're going to have to do log of 24 times both of these, log of 9 times both of these. So we're going to distribute it. What that does is give us 5x log 24 minus 2 log 24. I think I wrote that not close enough to the 2. Log 24 is equal to x log 9 minus 1 times log 9, and we don't show the 1. Okay, notice where we have the x's here. Two of the terms have x's. So what we do now is put the x's and get the x's together. X's together, and you'll see why in just a moment. So I'm going to add 2 log 24 to both sides, plus 2 log 24, and I'm going to subtract x log 9 from both sides. So that makes this 0, and it keeps these logs all together. So what I have, or it keeps the x values on one side, I should say, all together there, minus x log 9 equals, we have a couple of choices here. Put the positive in front of the negative in front. It doesn't matter for this group here. I'll put the positive one in front. 2 log 24 minus log 9. And this is where the key thought comes in. These both have x's, which makes them a common factor. That means I can take x out of both of these and have 5 log 24 minus log 9 equals 2 log 24 minus log 9. And so what we have here is this x now is a coefficient, not a coefficient, is a common factor. We can divide both sides by this 5 log 24 minus log 9, and we'll divide both sides by that. 24 minus log 9. So this whole thing is canceled out by this whole thing because they're the same. And so what we get is the x by itself. And then when you put all of that in the calculator, this is the first step, and get it all, press enter, then do divide, and then put in parentheses the other thing. Make sure you put in parentheses, be very careful with that. And then you get 0.3037. So in this case, I'm going to leave it with the 4 decimal places here. Let's get that box. So when dealing with logarithms, when in doubt, go 4 decimal places. The exception, real exception, is application problems where you need a number that's sensical based on the situation that it is. And we'll actually do one of those in a moment. And now let's take a look at another couple of examples here using other techniques. Okay, the first one here, notice the minus and that these have the same base. That means we can use the quotient property. So we get is log base 3 of x plus 2 divided by x minus 1. Definitely a place to use the parentheses. Now we're going to use the reformatting method. We're going to change this from a logarithmic to an exponential function. Change from log function to exponential. And the way we do that is, first thing, take that 3 and you move it over here. Second thing, you take the exponent and you put it up there. Or you take the part that's on the right side, and you make it the exponent of it. And the third thing is that log 3 is gone. We don't need it anymore. So what we have left is x plus 2 divided by x minus 1. And at this point, since there's nothing else on that side, we don't have to use parentheses. That's a really good, thing to get used to. And then we have the number 9, because that comes from the 3 squared, because that equals 9. Okay, now let's pick it up over here. Okay, so let's go back to x plus 2, x minus 1 equals 9. And so what I'm going to do now is multiply both sides by x minus 1, x minus 1, x minus 1. This and this cancels out. So we have x plus 2 is equal to, and I'll put these in, 9x minus 9. And then I'm going to subtract x from here because I don't want to deal with the negative ones. 2 is equal to 8x minus 9. Let's add 9. Get 8x equals 11. Divide by the 8, and x is equal to 8 over 11, okay, which is equal to 1.375. And, oh, wait a minute, 11 over 8. I did do the 1.375 right, but I did not do the 11 over 8 correctly. Since it's divided by 8, it'll go through decimal places, and it will stop. So this one can be equal, not an inequality, or not an approximate, because it's not approximate, it's actually the full number. Doesn't need rounding. You could round it to 1.4, say, or 1.38, but again, with logarithms, you should not keep it as that many decimal places. So now, next, let's take a look at this one. Different technique with this one, because of using a natural log of x here. Okay, so here we can use a technique to get rid of the natural log, but we have to first clean it up. So clean it up first. So that means we're going to subtract 28, That gives us negative 5 natural log of x is equal to negative 15. Let's divide by that negative 5. We have that the natural log of x is equal to, well, 5 goes into 15 3 times. The technique we now use is that you can apply e to both sides, but when you do, whatever is on that side becomes the exponent to the e. And then, as a result, this part cancels out, and you end up with just the x by itself there on that side, not as an exponent anymore. It's equal to e to the third power, and that means x is approximately 20.0855. So go the 4 decimal places, and that e is a key on the calculator. It's on all scientific or graphing calculators. Now, next, let's get that right. Next is an application problem where we have a function that models the percentage of students who could recall the important features of a classroom lecture as a function of time, meaning as time goes on, how much do they remember? X represents the number of days since the lecture. So let's take a look at what happens here. Here's the graph of it. And this shows that after 1 day, there's about 95% that's remembered. And after 2 days, it looks like it's down to about 80. And let's say over 5 days, that means students only remember about 30% of it. After 9 days, they don't remember anything. Okay, so let's see. After how many days have all students forgotten the important features? All right, so to some extent, we can see that on the graph here. We can see that should be a 9. But let's do it alphabetically, or let's do it algebraically here. So when P of X is equal to 0, that means, well, let's actually do P of X equals 95 minus 30 log base 2 of X. So we're going to put this as 0 equals 95 minus 30 log base 2 of X. Subtract the 95 from both sides. So we have negative 95. Let's make sure I have enough space here. Negative 95 equals negative 30 log base 2 of X. We're going to divide by that negative 30 on both sides. So it should have been like minus 95 here. Negative 30. And so we get here, the negatives cancel and 30 goes into 95. So we go 4 decimal places and round only then. 3.1667, and that's approximately log base 2 of X. Okay, so now I'm going to write it, switch it around in equal or approximately is still going to be that we can switch them around as long as we keep the relationship the same with negatives and positives. And now we're going to use the technique of I'll bring it up to here, where we're going to change this from logarithmic to exponential function. Change from log to exponential function. So here we have log base 2 of X is approximately 3.1667. We're going to bring the 2 over here, and the 3 point so on is going to become the exponent. So X is approximately 2 to the 3.1667. And you put that in the calculator, and that's going to be that X is approximately 9 days. And notice that that 9 days does indeed match on the graph. We didn't have to have a graph to do it, but it does match. The techniques, though, we use are exactly the same. The only difference on this was that we put a 0 that it would be equal to, and we subtracted and divided, and then applied the changing from logarithmic to exponential functions. Okay, so now that should help with seeing how to use an equation like that. And here we had, with all these others, different techniques to use, whether it's using E or logarithmic, power property, quotient property, product property. So use all of those different things. Sometimes there's factoring. Sometimes you distribute at different parts, like we did it sometimes. Pull out an X as a common factor. So practice all of these things to make sure that you can solve exponential and logarithmic equations. I hope this helps. Thank you for watching and listening.